Okay, topic 8.1 in the IB syllabus is the energy problem. This is probably the biggest problem that humanity is facing right now. I shared with you in the slides a video, a TED talk from Al Gore. Al Gore was the author of that famous movie, The Inconvenient Truth, that gave us eye-opening on the problem on climate change. It was really depressing. All the facts were negative. We were facing the end of humanity and the end of civilization. This was 20 years ago. But now he gave a TED talk that is the one that I shared with you. That is the case for optimism in climate change. The case for optimism. So he's talking about optimism, and I like in climate change. There is a case for optimism in climate change. This TED talk was done in 2016. And basically what he's saying here is, okay, we have a problem. And the problems, I like to think, that are like the tails of the animals. Animals come with tails. Problems come with solutions. No animal would be given by nature a tail that he cannot handle. So this problem is something that we should be able to handle. In that talk, in the TED talk, he states three questions. The first question is, must we change? Do we need to change? Must we change? That was the first part of the talk. And of course, this is all bad news. Yes, we must change, no doubt. And he gives some tremendous facts. For example, he mentions that, okay, we know that the air is thin, right? The atmosphere is thin, is very, very thin. Like, if you consider the world like an apple, the atmosphere is just the peel of the apple. It's tiny, tiny, tiny. And into that tiny space, we are throwing, I think he mentions something like 110 million tons per day of pollutants. That, in terms of heat, is the equivalent of, he says, something like 400,000 Hiroshima bombs every day. Every single day of the year, we are throwing 400,000 Hiroshima bombs to the air. Another fact that we are more or less aware of is that 80% of the fuel, of the energy that we use, is based on carbon. So that creates carbon dioxide, greenhouse gases, global warming, right? So those are facts. The temperature of the Earth is increasing undoubtedly. The poles are melting, no doubt about that. There is extreme weather. We have floods, drought, extreme weather. We have lightning like never before, floods like never before, fires like never before. So we have climate refugees for the first time in the history of humanity. We have climate refugees, people that are escaping from heavy drafts and moving into cities, moving like Syria, from escaping not just from war, but from weather. I'm going to write this so that it's. In 2016, the World Economic Forum in Davos, stated that climate change is the number one risk for global economy. This is not just politicians. This is economists from all over the world, global economy. So we have a big crisis here. We need to change because not only the planet is in danger, our way of living is in danger. So, yeah, the first part of the video is all bad news. We need to change or else we will have more pandemic diseases, more increasing of sea levels, and all the consequences of global warming. In the second part of the video, he states another question. He says, okay, we must change, but can we change? Is it a problem that we can handle? Is this a tale that we can carry? Can we change? And here he brings good news. It's a big yes. A big yes. And he shares the fact that the best optimistic predictions for instance, solar farms 20 years ago were beaten by 68 times. So there are 68 more solar farms than it was predicted 20 years ago. There are 15 times more wind farms than the best optimistic predictions 20 years ago. So there is a change that was not predicted. The reasons for that exponential growth in the number of solar farms and wind farms, exponential growth like that, right? In a very short period of time, things are increasing faster and faster, is that we are reaching the grid parity point. What is that? The point at which it is best to invest in renewable sources of energy than in fossil fuels. It's cheaper. We're reaching that. Why? Because the cost of windmills and the cost of batteries is also dropping exponentially. So this is also something that is happening and was not predicted. Lithium batteries are now much more efficient and cheaper than the batteries that we used when we started using solar energy. So one of the things that he states in his talk is that this is the biggest business opportunity of the century. This is a fact. The century, okay, let's spell it right. Of the century. This is something that he says, right? And it's based on the fact that the investment, not only from public sector, 2/3 of the investment in renewable sources of energy comes from the private sector. So it's good business to everyone, right? And if it's good business, it will proliferate. So if you want to make money, you have to start investing in renewable sources of energy. Another good news that we'll discuss later on in this video is what is happening with nuclear energy. Nuclear energy is also, even though it's not a renewable source of energy, it is also giving us a lot of good news in terms of new technologies to recycle nuclear waste. We'll talk about this in more detail later. So can we change? Big yes. It is within us to change. It is within our possibility and capabilities of changing this. And the last question that he states in this wonderful talk, again, watch it please, is if we will change. I mean, we can, but will we change? And again, he says, here there could be some disagreement in terms of what is happening in the world, especially with Trump being the president of the United States. There could be some ups and downs in terms of optimism, but we definitely have a moral challenge. And he quotes Wallace Stevens saying, this is a wonderful quote, so I'm going to write it down. Wallace Stevens says, after the final no. After the final no, when it's about a moral challenge, after the final no, there comes a yes. And in that yes, the future of humanity depends. This is a wonderful quote. The future of humanity depends. So, examples of this in the history of humanity. The slaves' abolition movement. There was no after no after no after no until it finally became a yes. Women's right. Another example, women's right. Civil rights movements. LGBT rights. All these things have been always opposed by most of humanity, but after the final no, yes has to happen. He ends up the video with a wonderful quote, his own quote. He says, "The will to act is itself a renewable resource." So, yeah, the energy problem is a problem resource. Okay, let's write it down. The will to act is in itself a renewable resource. So, this is Al Gore. This is what he mentions at the end of the 20-minute talk. Yes, we will change. He thinks that it is our moral duty to solve the energy problem. Now, like with any other problem, if we want to solve it, we need to understand. So the first question, I'm posting some questions here. The first question is, what is energy? Okay, we have a problem with energy, but we need to know what energy is. Oh, we said many times, a system is a group of elements that uses energy to work, right? So energy is what a system uses to work. That's the definition of energy. What a system uses to work. That is a simple but good enough definition of energy, right? All systems work with energy. Those systems could be living systems, could be machines, cars, TV sets, whatever. What a system uses to work. What becomes work is energy used for a purpose, right? So there is always an efficiency, which is the rate of work over energy. Yeah, there is always some energy that gets dissipated in any transformation. This is energy that gets lost. So in terms to solve the energy problem, we need to think about ways to change the sources of energy that we use, and also decide what is worth working. What is the difference between working and wasting energy, right? Where does it come from? Where does it come from? We know that energy, the first source of energy is the sun, right? So the first source of energy is sun. And the sun is giving us enough energy every hour to power the earth for a whole year. That is another fact. So all other forms of energy, except for nuclear energy, all other forms of energy are indirectly energy that are derived from solar energy, like for instance wind energy or tidal energy. We can prove that everything that, even fossil fuels, depends on solar energy first. So that is probably the answer to the first question. Very simple answer. Energy is what we and any other system uses to work, and it comes from the sun, mainly from the sun. Okay, second question. Sources of energy. What sources of energy would do? Okay, we could draw two sets that are different. One is what we call renewable sources of energy, and the other one is non-renewable sources of energy. And here we put solar first here, right? Solar is a renewable source of energy. Biomass, using the gases that are liberated by organic matter that decomposes. Wind energy, which is also powered by the sun, right? Hydroelectric power, hydraulic energy, energy powered by rivers, by dams, geothermal energy. This comes from the earth. Heat coming not from the sun but from the earth. We dig a hole in the earth and we could transform cold water into vapor and use that vapor to generate a turbine. So this is renewable sources of energy. And of course, the non-renewable sources of energy, coal, gas, petrol, and all the derivatives, petrol, all those, and nuclear oil, petrol, and nuclear. Nuclear is non-renewable because we need to mine uranium, but it's very clean energy. We'll talk more in detail about nuclear energy. Even though it is non-renewable, there are plenty of resources available to power the earth for many, many years with the nuclear, with uranium that we have already mined. So we don't need to keep on mining. That's an interesting debate too. So this is about sources of energy. Okay. The next question in the slides, forms. The difference between sources and forms. Yeah. So first we need to distinguish between primary and secondary forms of energy. This is a distinction that the IB wants you to know, right? Primary is energy that is extracted as it is found in nature without any change, without any transformation. For example, I don't know, wood. Wood is a primary form of energy. Uranium, wind, it doesn't need any transformation, tides. So these rivers, as it comes, right? But secondary is energy that comes from a primary source and then is transformed into another form of energy. For example, we can burn fossil fuels to create heat in a water boiler. So heat from a boiler, or the generation of motion from turbine, batteries, all electric power stations are, we don't use electricity as it comes from nature because in fact, electricity, the natural form of electricity in the form of lightning, we don't use it. But all the other forms of electricity are secondary because we are transforming motion of a generator to create electricity. So in any process or transformation that happens, we're talking about secondary forms of energy, or secondary energy, and primary energy, energy that comes as it is in nature without any kind of transformation. That is one distinction that the IB wants us to know. But then if we're looking at the forms of energy, and again I like to look at the elements of nature, right? Earth, water, air, fire and space. We can think of forms of energy that are connected to the element earth, and these is, see, mechanical energy, kinetic energy, gravitational energy, bodies moving, bodies, elastic energy, or chemical energy in fossil fuels. These forms of energy come from the earth. Forms of energy that come from the water, we can talk about tidal energy, we can talk about dams, hydroelectric energy, or rivers pushing the energy flow. If we look at the air, we are looking at windmills. It's mechanical energy, but connected to the motion of air pushing windmills. And then the energy that comes from the sun, 2 different or 3 different forms of energy. One has to do with heat, so we could have solar heaters. We are absorbing the heat directly from the sun. Another form of energy could be light. And solar panels, transformation of energy into electricity. That is another form of energy. And then the energies that are connected to the space element. Anything that has to do with motion in space. For instance, electric energy, it's the motion of electrons in space, right? So electric energy is associated to the space element, nuclear energy. So here we have at least 2, 4, 6, 8, 10 forms of energy. Some are renewable, some are non-renewable, but it doesn't matter. These are the forms of energy that we use and we know. Are these all? Oh, there are more. There could be more. For example, nuclear energy was not known a few years ago until the power of fusion and the power of fission was discovered. So these are the forms of energy connected to the elements in nature. Third fact. The world energy consumption matrix. This is taken from this source. You see, around 80%, as we said before, is burnable fossil fuels that contribute to the global warming, and only 20% or 21% of the world's energy consumption matrix is renewable, and these are the different kinds of renewable energies. So this is something to look into carefully and understand the importance of investing in these renewable sources of energy, which could be increasing the slice of this pie into a more and more renewable energy in the world. What is a Sankey diagram? Another important tool. It's a tool that we have to understand the energy transformations. Basically, a Sankey diagram is a representation of the flow of energy. The width of these lines is proportional to the, for example, if this is 100 joules, this could be, 100 or 10 centimeters. And if this is 10 joules, this is 1 centimeter, right? So there is a proportion between the width of the flow and the amount of energy that is flowing. As we said before, this is work, and this is energy dissipation or energy lost, right? So this is a light bulb is very inefficient, while a LED light emitting diode is much more efficient, right? So Sankey diagrams are used in order to represent the flow of energy of a system, right? This is something that we use a lot in the IB. Okay. Is it possible for countries to run with 100% renewable energy? The answer is yes. Of course, some countries like Albania, Costa Rica, these countries run already with 100% renewable energy because they have mountains with lakes on top, so there is a lot of gravitational potential energy available. And very small population. Iceland has a lot of geothermal energy. Iceland is also a country that is almost sustainable in terms of energy. But a good example of a European country that is becoming more and more sustainable is Germany. Like they reached something like 80% of the consumption of energy, excluding transport, the grid powered by solar panels and wind farms. So is it possible for more and more countries to become 100% dependent on just renewable energy? The answer is yes, of course. Different countries have different solutions, but in this document, this video that I shared with you, you can find examples in the world of countries that are showing the way into clean